A farmer has 300 meters of fencing to enclose 3 sides of a rectangular area. The fourth side is bounded by a long pond and requires no fence. What is the largest area the farmer can enclose? Let's visualize the problem to help us find the maximum area. If we let the long side of the rectangle be S, and as we know that the total fence is 300 meters, so the remaining 2 sides of the rectangle become 300 minus S all divided by 2, as they are equal and opposite sides of the rectangle, and the fourth side does not require any fence as the problem says. And it's better to verify that the fence is divided right, as if we add the lengths of all the 3 sides, the sum equal to 300, which is the given length of the fence. Now we define the function of the area of the rectangle equal to the length into the width, and the problem now asks us to find the value of S for which the function of the area gives maximum value. There are 2 ways to do it. First is to plot the function on the graph and find the x coordinate of the maximum point that will be the value of S for which the function is maximum. But we will consider this problem by derivatives. That makes our work a lot easy and practical. And even if you do not have much knowledge about the derivatives, do not run away. I will try to explain the solution along the way. The first point to ponder upon is that the derivative at a point on the curve is the slope of the tangent at that particular point. And when the tangent is uphill, the derivative at the point is positive, as the slope of the tangent is positive. And in the case when at a point the tangent is downhill, the derivative at that point is negative, as the slope of the tangent is negative. Now it's your turn to have a guess. When the tangent is at the maximum point on the curve, what will be the derivative? To make this question easier, just ask yourself, what is the slope of the tangent at this maximum point? And you may have guessed right if you already know that the horizontal line has a slope of 0. And at the maximum point on the curve, the tangent is a horizontal line. Thus the derivative is 0 at the maximum point. So now we have transformed our original problem into a new one that requires us to find the point on the curve at which the derivative is 0. At a glance, it may look as difficult as the original problem, but actually not that difficult. If we analyze how the derivative is changing throughout the domain of the function, and to analyze it, we should keep in mind that the derivative is the slope of the tangent, and this tangent is changing at each point on the curve. And there should be some function that gives the slope of the tangent which is same as the derivative at a given point. And it turns out, thanks to Leibniz and Newton, that we can find that derivative function if you are just given the original function. And one of the simplest tools of derivative, and one which we are going to use in this problem, is the power rule, which is not difficult even if you are new to it. It just states that if a function is given in the form of x raised to power some constant n, we can find the derivative by moving the power of x in front of it and subtracting 1 from the power of x, and this new function will be the derivative of the original function. And just to be clearer, this rule even applies to the terms when they are separated by positive or negative sign. Now returning to the original problem, we calculate the derivative of the area function by using the power rule. And we need to calculate at which value of s this derivative function is equal to 0. And at that value of s, the area will be the maximum. And now the problem becomes way easier, as finding the roots of the equation is an easy task than finding the maximum point on the curve. So we let the derivative function equal to 0 and find the value of s that satisfies this equation. And solving it, we get s equal to 150. Hence, when the side s of the rectangle becomes equal to 150 meters, the fence covers the maximum area possible. At this point, I will admit that I have overlooked a key important point for the sake of simplicity, which you may have caught. The point is that when the tangent slope is equal to 0 at a point, that point is not always the maximum point, as the slope of the tangent is also 0 at a minimum point on the curve. And the big reason for which I have overlooked this problem is due to the reason that there is no minimum point on the area function curve which we are considering in this problem. And the second reason being that to judge whether the point at which the derivative is 0 is maximum or minimum is in itself a different topic, and I have already done a video about it, of which I have included the link in the description.